Algebra 2 word problems. Type 3 simultaneous equations. So we're going to do question 13 as our example on page 56 in our book. And we can see here that we have a diagram representing a reef, and it's the boundary of a reef. And then we have the linear path of a ship. So in other words, the path of the ship is going to pass through the reef. And we can see that clearly there are going to be 2 points on entering and on leaving the reef. So in other words, there's going to be 2 points of intersection. And we're asked, at what 2 points will the ship cross the boundary of the reef? So that should trigger that this is going to be a simultaneous equation question, because in order to find our points of intersection, we need to know what our coordinates for x and y are going to be. Now we can clearly approximate by looking at the diagram and reading off the graph, but we want to find the exact values. So we start by writing down the 2 equations. So we have the linear equation is 2x plus y equals 6. So we call that equation 1. And the second equation is representing the boundary of the reef, which we can see is a circle. So it's x squared plus y squared equals 17. So we'll call that equation 2. So whenever we're dealing with a linear and a non-linear equation, so this one's the linear because it's an x and a y, so the highest power of x is 1. And this one here is the circle. Then we always take the linear, and our circle is the non-linear. And we're going to rearrange the linear equation to get one variable on its own. So if we look at 2x, well, x has a coefficient in front of it, which means I'll end up with a fraction if I try and get x on its own, because I'd have to divide everything across by 2. Whereas y, the coefficient is 1, so it's actually much easier to get y on its own there. So if I subtract 2x from both sides, I get y equals 6 minus 2x. So now I know that that's what y represents. So I take that linear equation and I'm going to sub it into the non-linear wherever there's a y. So in other words, we're going to sub y into 2. So we have x squared and y squared. So instead of y, we're putting in 6 minus 2x, but I have to then square that, and that equals 17. So if I'm squaring 6x minus 2x, that means 6 minus 2x multiplied by 6 minus 2x. So again, our quick way is we look at 6, so we square the first term, so 6 squared is 36. We multiply the 2 terms and double it. So 6 times minus 2x is minus 12x, and if I double 12x, I get minus 24x. And then I square the second term, which is minus 2x, so that becomes plus 4x squared, and that equals 17. So if I bring everything to one side, so to the left-hand side, I'll then get a quadratic equation. So I have x squared and 4x squared is 5x squared. Then I have a minus 24x. And then if I subtract 17 from both sides, I get 36 minus 17, which is plus 19. I can't simplify that by dividing across by 5, so I'm going to go straight to solving my quadratic. So I can say 5 times 19 is 95. So my factors of 95 that multiply to give me 95 and add to give me this minus 24 will be minus 19 and minus 5. And if you can't figure those out, don't forget you can of course use your minus b formula to solve your quadratic. So instead of minus 24x, I'm going to put in minus 19x minus 5x. So then I group my first 2, group my second 2, and look for a highest common factor. So there's nothing common between 5 and 19, but there is an x common. So that leaves me with 5x minus 19. There's nothing common between minus 5x and 19, so if I take out minus 1, that's the only thing I can find that's common. Then that leaves me with 5x minus 19 equals 0. Both these brackets are now the same, so again I take out my highest common factor. So I have 5x minus 19 times x minus 1 equals 0. So by letting both of those factors equal 0, because they multiply to give me 0, it means one of them or both of them must be 0. Well then, that gives me x equals 19 over 5, or x equals 1. So now I have two values for x. I'm not finished because, again, if I go back up to the diagram, it says at what 2 points will the ship cross the boundary of the reef? And of course, that means there has to be a corresponding y value. So there are two x values, hence there must be two y values. So again, if I go back up to the start here, equation 1, I had rearranged to get y equals 6 minus 2x. So that means if I take these two values for x, so in other words, we got x is equal to 19 over 5. So that means that y must be 6 minus 2x. So that gives me 6 minus, and then 19 times 2 is 38 over 5. And again, if I simplify that, that gives me minus 8 over 5. So that means the point is x, comma, y. So again, writing it as my coordinates. So x and y. And then I had a second value for x, which was 1. So that is going to be y is equal to 6 minus 2 times 1. So y is equal to 4. So the two coordinates where the ship crosses the boundary of the barrier is 19 over 5 minus 8 over 5 and 1, 4.